Experimental evaluation of PHP's cURL library performance in distributed computing environments. The cURL library, a widely used tool for connecting to and communicating with external resources, plays a crucial role in distributed systems like Apache Hadoop. In these environments, cURL facilitates communication between different components, making it essential for server, desktop applications, and IoT devices. However, observations of decreasing download speeds from Web HDFS with increasing file sizes prompted an investigation into the performance of the cURL library. To determine if the cURL library or the Web HDFS API was responsible for the decrease in download speed, the authors conducted a series of experimental analyses. The results indicate that the cURL library itself is the primary cause of the decrease in download speed, rather than the Web HDFS API. This finding highlights the importance of optimizing the cURL library to ensure efficient communication in distributed computing environments. The cURL library is deeply integrated into various operating systems and is used in different programming languages, making it a fundamental component of the IT industry. However, its widespread use also raises concerns about security risks associated with connecting electronic devices to the Internet, particularly those with limited processing power that cannot support reliable security protocols. The study's findings contribute to ongoing efforts to improve the scalability and efficiency of web services and applications, especially those utilizing REST-based services and distributed frameworks like Apache Hadoop. The results emphasize the need for further optimization of the cURL library to ensure efficient communication in distributed computing environments. In the realm of big data processing and analysis, the Hadoop ecosystem is a comprehensive suite of tools, with Apache Spark being a prominent tool for handling both batch and streaming data. To leverage these tools, a company must first integrate its data with the Hadoop cluster. A previously proposed architecture enables the integration of heterogeneous data to a remote Hadoop cluster, allowing for the storage and processing of both streaming and batch data. This architecture relies on the Web HDFS API for remote access to the Hadoop Distributed File System, HDFS. The Web HDFS API is a REST-based API that enables third-party applications to connect to the remote HDFS file system and read, write files. The cURL library is commonly used to access the Web HDFS API, and its performance and throughput are crucial in handling large data files. This paper presents an experimental analysis of the PHP's cURL library performance and throughput, as well as the Web HDFS API. Prior experimental analysis of the Web HDFS API throughput revealed that read speeds decrease with increasing file size, while upload speeds remain constant. This unexpected issue prompted further investigation to determine whether the cURL library or the Web HDFS API is responsible for the decrease in download speed. The experimental application is built in PHP, utilizing the PHP Hadoop HDFS library to access the Web HDFS API. The library composes necessary HTTP requests to access the API, facilitating access without requiring knowledge of the Web HDFS API itself. The experimental system architecture is presented in Figure 1, which illustrates the communication between the PHP application, the PHP Hadoop HDFS library, and the Web HDFS API. The experimental analysis aims to determine the performance and throughput of the cURL library and the Web HDFS API, independently and separately, to identify the cause of the decrease in download speed. The experimental evaluation of the cURL library is motivated by the need to understand its performance and throughput in handling large data files. The results of this analysis will provide insights into the capabilities and limitations of the cURL library and the Web HDFS API, enabling the optimization of data processing and analysis workflows in the Hadoop ecosystem. The experimental setup for the study of Web HDFS API performance involves a Hadoop cluster consisting of 10 rack-mounted servers, with one name node and 9 data nodes connected through a 24-port gigabit switch. The client application runs on a laptop computer with 7 Philippine pesos and 30 centavos. 23, cURL library version 7.70, and uses the PHP Hadoop HDFS library to interact with the Hadoop Distributed File System, HDFS. Initial experiments reveal that files are downloaded from HDFS at high speeds, nearly reaching the maximum throughput capacity of the network, regardless of file size. This indicates that the cURL library distributed with the PHP interpreter is likely the cause of the read speed decrease in previous experiments. To further investigate the cURL library's performance, a revised architecture is proposed, where the PHP Hadoop HDFS library is removed and the Hadoop cluster is replaced by a single web server running Apache HTTP Server version 2.4.41 on Windows 10.2.2H2. The server hardware consists of an Intel i5-4570 at 3.20 GHz, 4 cores, and 16 GB RAM. The client experimental application remains the same, using the same laptop computer and connectivity settings. Experiments are conducted on both 1 Gbps and 100 Mbits networks. The revised architecture focuses on testing the cURL library independently, using plain HTTP GET requests to the file resources hosted on the Apache HTTP server. This setup allows for a more precise evaluation of the cURL library's impact on the read speed. The experimental study utilizes the same dataset as previous experiments, consisting of files ranging from small to medium, 10,100 megabytes, with 10 megabytes increments, medium, 100,300 megabytes, with 50 megabytes increments, and large, 5,001,500 megabytes, with 500 megabytes increments, in size. The results obtained using PHP's cURL library demonstrate a significant decline in download speed as file size increases, with a pronounced effect observed for large files. Visualization of the download speeds for small to medium files, and large files are presented in figures 3, 4, and 5, respectively, showcasing a rapid decline in download speed with increasing file size. A direct comparison of these results with those obtained during the experimental evaluation of the Web HDFS API is presented in figures 6 and 7, which display the comparison for medium and large files, respectively. The authors present a comparative analysis of download speeds from a server's file system over HTTP and from HDFS through the Web HDFS API, as depicted in figures 6 and 7. The study measures download speeds for files ranging from 100 to 300 megabytes and 500 to 1,500 megabytes, respectively. The plots reveal that the read speed lines for both scenarios exhibit similar patterns, with a notable decrease in speed as file size increases. This similarity is particularly evident in Figure 7, where the lines are almost identical, indicating that the absolute values of read speed are comparable. The authors conclude that the decrement in read speed is not attributed to the Web HDFS API, but rather to the PHP's cURL library, which is used for reading data. This assertion is supported by the observation that standalone command-line cURL tools, tested on both Windows and Mac OS, achieve constant download speeds for all file sizes. The findings of this study suggest that the Web HDFS API is not a limiting factor in data exchange with the Hadoop Distributed File System, HDFS, and high speeds can be achieved. Instead, the network speed itself appears to be the primary constraint. The authors emphasize that this conclusion specifically applies to the PHP's cURL library and not to the entire cURL project. This research study investigates the performance of writing and reading files to and from an HTTP server's file system and a distributed HDFS using the Web HDFS API with the cURL library for PHP. The key findings indicate that the speed of writing files remains constant, limited only by network capacity, regardless of file size. Conversely, the speed of reading files decreases rapidly as file size increases. This decrease in read speed is attributed to the implementation of the cURL library rather than the server itself. It is crucial to configure the PHP interpreter to use a larger amount of RAM memory than the size of the files being read, as data transfer occurs in multiple small network packets that must be stored and arranged in a common buffer within the RAM memory. This study builds upon previous research in the field of distributed systems and HDFS, highlighting the importance of optimizing system configurations for efficient data transfer. The findings have implications for the development of distributed systems and applications that rely on the Web HDFS API and cURL library. The study is supported by Project 23FEEA01, Development of Models and Simulations with Different Application Areas, funded by the Research Fund of the Angel Kanchev, University of Ruse.